So today we're going to talk about the imaginary unit and complex numbers. And we're also going to be doing a little bit of reducing radicals with this. So first of all, the imaginary unit. We know you've talked about the real number system for years, and we have real numbers because we also have imaginary numbers. Imaginary numbers are those where it's the square root of a negative number. So the letter I we're going to use for the imaginary unit, and I is equivalent to the square root of -1. So if I wanted to find out what the square root of -4 is, that's really like saying the square root of +4 times the square root of -1, if we want to think about breaking it down. And the square root of +4 is a 2, and we just learned that the square root of -1 is really I. So the square root of -4 would be 2I, whereas the square root of -3 would be the square root of +3 times the square root of -1. I can't take the square root of +3. That's an irrational number, so I'm going to leave it as the square root of 3. But I can take the square root of 1 as I. So I'm going to put that in front, and then the 3. Typically speaking, the I would go after a rational number and before an irrational number. We don't usually write it after because it looks like it could be under the symbol with it, and we don't like to do that. So here, square root of 72, this one's a little bigger, right? It's not a perfect square, but it can be reduced. So I'm going to break this down as the biggest perfect square that goes into 72, and I'm going to do this without a calculator. Everything I'm going to do today is without a calculator, is 36, right? 36 times 2 is 72, and then we still had the -1 in there. So I could take the square root of 36 is 6. I could take the square root of -1 is I, and I'm not going to touch the 2, so square root 2 like that. And for this one, the -9, 9 is a perfect square. That's really right. 9 times -1. So we have a -5 times a 3 times that I. So this would be -15I. So here's some for you to try. You can pause. The answers are posted in the blank notes on Google Classroom. So a complex number has a real part and an imaginary part, and the standard form is the real part first and the imaginary part second. So we can add and subtract, we can multiply and divide complex numbers. So if I want to add or subtract these complex numbers, I'm just going to combine like terms. If it's a plus, just combine like terms. So the like terms would be the 8 and the 5, because those are both the real components. 8 plus 5 is 13. Then I have a -I and a +4I. We're essentially treating it like it's a variable. So -I plus 4I is plus 3I. And that would be our answer. This one has a negative. So we have to distribute the negative to both things, right? We're doing a -3 and a -6I, so plus 6I. And now this is gone. So I have 7 minus 3 is 4. -6I plus 6I is gone. So my answer is just 4. Here we have the -3 that has to go to both of these things, but this plus 5I is not in the parentheses, so the 5I does not get the -3. So I'm going to rewrite the whole thing. 13, this is going to be -6. -3 times 7I is -21I, and then plus 5I. So my like terms, 13 minus 6 is 7. -21I plus 5I is -16I. So here's some for you to try. You can pause. The answers are posted in the blank notes on Google Classroom. Okay, so I squared is equivalent to I times I. And I times I is really -1 times -1, right? -1 times 1 is 1. So the square root, oh, sorry, I'm doing this wrong for you guys. Let me look at this as -1 squared. That's what we want to see it as, right? And we know that the squared cancels out the symbol, so I squared is really equal to -1. If I'm doing I cubed is really I squared times I. So if we just said that I squared is -1 times another I, then that's going to be -I. For I to the fourth, that's really I squared times I squared. And I squared was -1 times another -1. Negative times negative is a +1. And I to the fifth, right? I squared times I would be -1 times -1 times I. So that's +1I. So looking at this, the powers of I repeat in this pattern. So I to the first would be just I squared was -1. Then we had -I, then we had 1, then we had I, right? That's what we've done in the chart. So following this pattern, I went I, -1, -I, I, -1, -I, and so on and so forth. So that means it's repeating in a pattern of 4. If we divide the exponent by 4, the remainder should tell us what the answer is. So if I have I to the fifth and I divide that by 4, that goes in once with a remainder of 1, so that's equivalent to I. If I had I to the seventh, divide that by 4, right? Goes in once for a remainder of 3, I to the 3 was -1. So if you can remember this 4 here, right, and obviously going into 4 would go in evenly, so the remainder here is really 0. This would be our pattern, right? Remainder of 1 is I, remainder of 2 is -1, remainder of 3 is -I, remainder of 4 is I. So let's simplify each of these expressions to either I, 1, -I, or -1. So I to the 18th, right, goes in 4 times. 4 times 4 is 16, so that's a remainder of 2, right? A remainder of 2 should be -1. 33, so 4 times 8 is 32, so that's a remainder of 1. Remainder of 1 should be I. And if it helps here, right, this was a remainder of 1. This was a remainder of 2. These are not going in the right order, right? Then it went to a remainder of 3, then a remainder of 0, right? Not 4, 0. All right, let's just double check that. Remainder of 4 or 0 was 1. Remainder of 3 was -I. Remainder of 3 was -I. There we go. So 48, that divides by 4 evenly, right? So that would be a remainder of 0. So that answer would be 1. This, I'm going to multiply it first. And by multiplying, I really mean add, right? When you multiply like bases, you add the exponents. So this is really I to the 31st power. We know that 4 times 7 is 28. So that would be a remainder of 3. And a remainder of 3 was -I. And here, this 3, I mean, obviously the answer is not going to be any of those. The answer is going to have a 3 in it. But it's 3 times I to the, now here they get multiplied. So that's 12. So 12, 4 goes into evenly, so it's a remainder of 0. So that would be 1. So 3 times 1 would give us an answer of 3. So here's some for you to try. You can pause. The answers are posted in Google Classroom in the blank notes. All right, example 4. We're going to multiply the complex numbers, and then we're going to write the answer in standard form. So we're going to have to keep a little bit of that last thing, but the main thing we have to remember here is that I squared is equal to -1. That's really the only thing we have to remember for this part. So here, if I were to distribute this 4i to both of them, 4i times -6 is -24i. 4i times I is 4i squared. So anytime I end up with an I squared, I'm going to replace that with a -1. So 4 times -1 is really -4. And then I'm going to put the imaginary part second because they said standard form, -24i. And that's my answer for that one. I can't have, I don't have any like terms I can combine. The only thing I could do is get rid of the I squared and turn it into -1. So for our next one, now we're going to distribute the 9 to both, and we're going to distribute the -2i to both. So that's going to give us -36 plus 63i. Negative times negative is a positive 8i. Negative times positive is a negative 14i squared. So this -14 times the -1 is really plus 14 now. So like terms, -36 plus 14 is -22. 63 plus 8 is 71. All right, and our final one, we have 4 minus 5i squared. I'm going to rewrite that as 4 minus 5i times 4 minus 5i because we're not allowed to distribute the power. So instead, we're going to distribute the 4 to both and the -5i to both. So distributing the 4, we get 16 and -20i. Distributing -5i, we get a -20i, and negative times negative is positive 25i squared. Right? This is going to turn into -25. So 16 minus 25 is -9. -20 and -20 is -49. All right, there's some here for you to try. You can pause. Answers are posted in the blank notes on Google Classroom. So a conjugate or conjugates are pairs of two-part terms, binomials, where you flip the middle sign. And what we mean by that is if I had the term 5 plus 6i, the conjugate of that would be 5 minus 6i. We're just taking the same two things, same places, but we changed the middle sign. So here, you're going to find the conjugate of 9 minus 4i. You can pause. Answers posted in the blank notes on Google Classroom. So when we're dividing by a complex number, you can multiply both the numerator and denominator by its conjugate to do the division. So if I want to simplify 7 plus I over 3 minus I, the conjugate of the denominator is 3 plus I. So I'm going to multiply the bottom by 3 plus I and the top by 3 plus I, because when you multiply both the top and bottom of a fraction by the same thing, you're not changing it, right? Because you're multiplying by 1, it's the identity, but it will allow us to not have this complex number on the bottom anymore. So on the top that was in parentheses 2, so we remember to distribute. We're going to have 7 times 3, which is 21. 7 times I is 7i. I times 3 is 3i. I times I is I squared, right, which is -1. So 21 minus 1 is 20. 7i and 3i is 10i. So now the bottom. 3 times 3, 3 times I, -I times 3, -I times I. So 3 times 3 is 9, plus 3 times I, minus 3 times I, minus I times I, which is I squared. So this will turn into plus 1. So we have 9 plus 1 is 10. Positive 3i, negative 3i cancel. So it's just 10. So now I could even simplify this further, right? Because everything here divides by 10, both parts on the top and the one part on the bottom. So if I divide everything in this problem by 10, that's going to be 2 plus 1i. And that's my answer. For B, we're going to multiply both the top and bottom by the 8 minus 7i. So for the top, 72 minus 63i plus 24i minus 21i squared. So that's really plus 21. So that's 93 minus 63 and 24. That's 39, negative 39i. So that's our numerator. Our denominator, 8 times 8 is 64. then negative 56i, then positive 56i, then negative 49i squared. So that's going to become plus 49. So 64 plus 49 is 113. And our negative 56i and positive 56i cancel. There's nothing that goes into both 93 and 39. Actually, that's not true. 3 goes into both, but 3 does not go into 113. So that's it. That's as far as we can go. That's the end. So here's one for you to try. You can pause. Answers posted in the Google Classroom in the blank notes. So what we have left is some NJGPA practice. So in our NJGPA practice, it says using the choices below, write the expressions in the box that represents an equivalent value. So the square root of negative 4, remember, was the square root of 4 times the square root of negative 1. So that was a 2 and an I. So that means that would go here, square root of negative 4. 2 times I to the third was 2 times I squared times I. So that was 2 times negative 1 times I, which would be negative 2I. So that would go here. 2I squared is just 2 times negative 1. So that's negative 2. So that would go there. And then 2 times I squared squared is 2 times I to the fourth, which is 2 times a positive 1, which is 2. So that would go there. In the next one, we're going to do something similar, but we want to know, is it equal to 1, equal to negative 1, or neither? So here, 2 plus I squared. 2 plus I times 2 plus I. So that's 4 plus 2I plus 2I plus I squared, which would be minus 1. So 3 plus 4I, that's not 1 or negative 1. So that would go in there. I to the sixth. So that's I to the fourth times I squared. So that's 1 times negative 1. So that would give us negative 1. So I to the sixth would go in there. Negative 1 times I is just negative 1I. That's not either of those, right? There's an I in it. So that would go into neither. And this would be I to the 12th. Right? Dividing that by 4 gives me a remainder of 0. So that should equal 1. For 3, which of the following is equivalent to this? So we know I plus 3 is going to stay I plus 3. And then I'm going to distribute this. So that's going to be 2I squared minus 4I. And this could turn into negative 2. So 3 minus 2 is 1. I minus 4I is negative 3I. So 1 minus 3I is the same as a negative 3I and a positive 1. So these are not written in standard form. Right? This would have been standard form. This is not standard form. So I just rearranged it, right? The 3 had the negative, the 1 was positive. So that would be choice D. For 4, they want to know which expression is equivalent to x times y. So we're just going to take the 6 plus 3i and the 10 plus 8i, and we're going to multiply them. So that's going to be 60 plus 48i plus 30i plus 24i squared, which is negative 24. 60 minus 24 is 36, and 48 and 30 is 78. So 36 plus 78i would be choice B. And our final one, what is the standard form of 9 plus 3i squared? So remember, we cannot distribute the power. We're going to do 9 plus 3i times 9 plus 3i. That's going to be 81 plus 27i plus 27i plus 9i squared, which is minus 9. So 81 minus 9 is 72. 27 plus 27 is 54. So that would be choice D. And that is imaginary and complex numbers.